everyone. So tonight's notes are going to be on function notation. It's just a slightly different way of writing equations than what we're used to in 8th grade. So to start off, let's say we have the equation y equals 9 minus 4x. That's like an equation that you guys have seen in 8th grade. Well, we're going to say that represents a function, and I'm going to explain that in a little bit. So to use function notation, all we're going to do is replace our y with an f of x. And whenever we see parentheses, we think multiplication, but using function notation, we got to be very, very careful to understand that the parentheses here does not mean multiplication. So we call this f of x. So starting here, f of x is read as f of x. And we say that because our f is going to depend on what our x is. So the output value of the function f for the input value x. So what does it mean when I talk about output, input? Let's say I have my value of x, which we are used to. That's what we've done in 8th grade, x and y. So x I'm going to call my input value. And imagine a function is like a big machine. So we have this input that we're going to put into the machine. The machine is going to do its work, and then it's going to put out some value depending on what we put into it. So x is going to be our input value. I'm going to put that into my function, which in this case is f of x equals 9 minus 4x. It's going to do its work, and then it's going to spit out this output value that we call f of x. So f of x is going to depend on whatever input value we're putting into the function. So this is going to change depending on whatever this value is. So let's see an example. So let's say I have an input value of 2. All that means is that my x is going to equal 2. I'm going to input that into my function. So when I input it into my function, I'm just going to go ahead and replace all of my x's with 2. So instead of saying f of x equals 9 minus 4x, it's going to become f of 2 equals 9 minus 4. And instead of 4 times x, it's going to be 4 times 2. So we want to be very careful when we say f of 2, this is not multiplication. But then when we substitute into this part of the equation, instead of 4 times x, it's going to become 4 times 2. So in this case, it does mean multiplication. So again, here is going to be f of 2 equals 9 minus, and we want to do the multiplication first. So 4 times 2 is 8. Then 9 minus 8 is 1. So f of 2 is equal to 1. So I input a value of 2, and then the output is going to be 1. So f of 2 is equal to 1. And if I had to make a statement just to kind of simplify everything, that just means when my x is equal to 2, then my f of x, my output, is going to end up being 1. And if you get super confused by the f of x, just remember f of x is the same thing as y. So it would be the same thing as saying when x is 2, then y is equal to 1. Now let's say I want to change my input value. So instead of using 2, I'm going to change my input value to 11 now. And then because I'm changing my input value, that's going to affect what my output value becomes. So here x is equal to 11. I'm going to input that into my function. And what that means is just replacing x with 11. So my function is going to become f of 11 is equal to 9 minus 4. And instead of 4 times x, it's going to be 4 times 11. So f of 11 is going to equal 9 minus 44. And then when I do 9 minus 44, I get f of 11 is equal to negative 35. So when I input a value of 11, I'm going to get an output value, f of 11 equals negative 35. And that would be called my output value. So if I had to summarize that, it's just when my x is 11, then my f of x is going to end up being negative 35. And if we get confused by the f of x, just remember it's the same as y. So it's similar to saying x is equal to 11, then y equals negative 35, if we were using our x and y still. Okay. So one thing about function notation, when we have x and y, you can solve for x or you can solve for y. Same thing with function notation. So you can also be given the output value, f of x. So instead of replacing the x, now we're going to replace our f of x. And then we want to go ahead and solve for the input value, which is our x value. So what does this look like? An example, given f of x equals 5x minus 1, I want to find what my x is when f of x equals 9. So I want to be very careful. I'm not replacing x anymore. I'm replacing f of x. So I'm going to replace f of x with 9. So f of x is over here. That means that that is now going to become 9 is equal to 5x minus 1. And that looks like an equation that you guys have seen in 8th grade. If I want to solve for my x, I just have to add 1 to both sides, right? Because then it creates my 0 pair. So I get 10 is equal to 5x. And then if I divide both sides by 5, I get 2 is equal to x. Another example. Let's say given f of x equals negative x plus 2. Find x if f of x is equal to 6. So again, my f of x is equal to 6. So I'm going to replace my f of x with 6. And my f of x is on this side. And I want to replace that whole thing. So it's going to become 6 equals negative x plus 2. So I want to get rid of that 2. I'm going to subtract 2, so I get a 0 pair. And I have 4 equals negative x. And then remember, I can rewrite this, instead of negative x, I can rewrite it as 4 equals negative 1x. So then I could divide both sides by negative 1. And I get negative 4 would be equal to x. So remember, if I do not have a coefficient in front of a variable, I can always put a 1 there. So instead of negative x, it just becomes negative 1x. And then the final thing we want to know about function notation is sometimes we use different variables. So it's not always f of x. I could have a f of x, I could have a g of x, I could have a p of x, I could have a h of x, an m of x. Sometimes we could even change the x, which we'll talk about in later lessons. So it could be f of t, f of n. You just want to get used to there's going to be a value inside the parentheses, and then depending on what that value is, it's going to change what our output value is. So the variables don't really change anything. There's still going to be an input value and there's still going to be an output value. And I put a note up here. When given multiple functions, make sure to use the correct function. So for A, it says find g of, I accidentally put x, but let's find g of 5. Okay. So what that means is the 5 is in the parentheses, my x is going to equal 5, and I want to make sure to use my g function, and my g function is g of x equals negative 3x plus 1. So I'm going to go ahead and replace x with 5. So it becomes g of 5 equals negative 3 times 5 plus 1. I want to multiply first, so negative 3 times 5 is negative 15. So I have g of 5 equals negative 15 plus 1. Negative 15 plus 1, negative 14. So g of 5 equals negative 14. And then that just means when x equals 5, then g of x equals negative 14. And then let's say I have a different equation. So here I have f of 3. So my x is equal to 3. And then I want to make sure I'm using the correct function. So because it's my f function, I'm going to use the function right here, x squared plus 7. So f of x equals f squared plus 7. And I'm just going to replace x with 3. So this is going to become f of 3 is equal to 3 squared plus 7. And remember, we want to do the exponent first, and 3 squared is the same thing as 3 times 3. So that becomes f of 3 is equal to 3 times 3 plus 7. 3 times 3 is 9, so f of 3 equals 9 plus 7. 9 plus 7 is 16, so f of 3 equals 16. So that just means when x is equal to 3, then f of x equals 16. And then for my final two, for C, let's say I have p equals negative 2. That means that my x is equal to negative 2. And I want to use my p function. And my p function is p of x equals 2x plus 9. And I'm going to replace my x with negative 2. So that's going to become p of negative 2 equals 2 times negative 2 plus 9. I want to multiply first, so 2 times negative 2. I get p of negative 2 equals negative 4 plus 9. And then negative 4 plus 9 is going to give me 5. So p of negative 2 equals 5. And that means that when x equals negative 2, then my p of x is equal to 5. And then for my final problem, if I have g of 0, that means that my x is going to equal 0, and I want to make sure to use my g function. So that's going to be g of x equals negative 3x plus 1. And I'm going to replace my x with 0. So that's going to become g of 0 is equal to negative 3 times 0 plus 1. Negative 3 times 0 is 0, so I get g of 0 is equal to 0 plus 1. And I just end up with 1. So g of 0 is equal to 1. And that means when x equals 0, my g of x is going to equal 1. So that's how we use our function notation. And then as we go on through the week, we're going to be using more and more function notation. So hopefully you guys get used to it. If you have any questions, just let me know.